Hello and welcome to this webinar. The topic presented within is a snapshot of the Exploration Incentive Scheme Co-funded Drilling, the results and impacts from the first drilling round in 2009 through to round 17, which completed drilling in June 2019. My name is Charlotte Hall and I am the EIS Coordinator. Rounds 1 to 17 had 1,290 eligible applications in both the general and prospector fields. About 63% of these were successful in receiving an offer to refund of 50% of direct drilling costs. Historically, it has been shown that only 60% of projects which were offered co-funding will be completed. The combination of withdrawal rate and the fact that not all drilling projects will use the full amount offered has required the program to have 2 co-funded rounds in a 12-month period to ensure the $5 million allocated per year is utilised. One of the requirements for co-funding is that a final comprehensive report is compiled, and after a 6-month confidentiality, reports are released to open file. This enables new results and innovation to be available to the wider exploration community much sooner than information submitted in statutory annual reports, which have a 5-year confidentiality period. 479 reports with over 8,700 drill holes and associated information are now open file. This has involved work across nearly 600 tenements. Later in the presentation, there is further discussion on the tenements and drilling. The short term for this review across 17 rounds did not allow for all completed projects to be reviewed. However, 83% of the projects and company results were investigated to provide a fair and reasonable indication of the success of the co-funded drilling program. As mentioned in the opening address, only about 60% of projects which are offered co-funding are completed. The question was asked if withdrawal was across the board, regardless of how well companies scored against the assessment criteria in the application process. The result of 2 methods to test this are shown here. Yellow represents completed projects and brown withdrawn projects. The top image takes the absolute score, highest to lowest, whereas the second method, the lower image, is via the margin. This is the value of the score exceeding the cutoff score, with ranking from highest margin to the lowest. The latter is because the cutoff score is not a uniform number across all rounds. Both results indicate that withdrawal is not influenced by technical merit of the proposed project, but by other criteria external to the EIS. A similar question was asked in terms of the dollars offered. Are offers not drilled distinguishable from offers drilled? Again, all offers are ranked 2 ways. 1, by the dollars offered, highest to lowest, whereas the second method is in accordance to the application date, i.e. from round 1 to 17. As with the previous slide, the data looks to have a fairly random distribution of time, meaning if more money is offered, it does not mean the drilling is more likely to be completed. The next couple of slides will not be discussed in detail, but the PowerPoint will be available on the DEMERS website so that the viewer can read at their leisure. It should be noted, at the end of round 17, over 847 kilometres of drilling had been completed. The amount of data reviewed in this project is shown in the blue text. Reverse circulation and diamond drilling dominate the co-funded drilling, contributing almost equally in terms of aggregated depth drilled, but noting that only 720 diamond holes versus almost 3,000 RC holes. Most of the technical impact is from RC and diamond drilling, but there are contributions, albeit lesser, from other drilling methods. This image provides a graphical representation of the previous slide in the discussion and clearly demonstrates that most meters drilled are by diamond and RC methods. If the drilling method type is reviewed, then it is air core drilling that is the front runner for the number of holes drilled. In two cases, seen here, the submitted final report has characterized holes as water holes. This is where the applicant has chosen to label the holes with the final use of the hole post-drilling. We are now seeing more of this with the sulfate of potash projects that are offered co-funded drilling. Deep exploration holes are a feature of the EIS co-funding in terms of the objectives of the scheme and in the longer-term value that the core provides to the state. At the end of round 17, there were 68 holes drilled with an end of hole greater than 1,000 meters, plus a further 154 holes between 500 and 1,000 meters. These provide an invaluable set of reference cores which are scattered across the state. An example of where these deep holes provide assistance are the Kalgoorlie-based deep holes providing confirmation of the stratigraphy, which will assist in the 3D modelling of the district in conjunction with the recently completed 7 2D seismic lines. Moving to this graph, we see the average depth by different drilling methods confirms the importance of diamond holes with an average depth of 430 meters, compared with air core that is only 46. Recently, we have seen the emergence of government initiatives to find strategic commodities. From round 18, which started in 2019, to the present day, about a third of all co-funded drilling applications list a strategic element. Historically, 482 completed projects suggest that about 33% will find mineralization with a strategic commodity, but not necessarily in economic grades. Some of the projects that did find strategic commodities did not have such elements listed in the application. If we now drill down a bit deeper into the information supplied in the open file reports from the short-term study, we see, as expected, nearly all have assay data, and then there is a drop-off to portable XRF and major oxide geochemistry. Some of the other trends identified show prospectors with gold projects are likely to only assay for gold, and certain companies dominate in the use of portable XRF. Interestingly, most of these companies using XRF are exploring in the Patterson origin in the state's eastern Pilbara region. This is an area which has seen a lot of co-funding and success in exploration in recent times. As expected, with the geological logs, these are a dominant feature in final reports. Where reports do not have geological reports, these are likely to be prospector-based, short auger programs, or maybe where an applicant has drilled and failed to submit the final report. In the latter case, this is rare, and we will endeavour to construct a stand-in report from the data sent in the interim report. With respect to downhole survey information, about 64% of reports will have this information. We then see a significant drop-off in other technical information, especially concerning petrophysical properties. One of the questions asked, is the co-funding a success in terms of discovery? This is not easy to answer, as discovery is an ambiguous term. It loosely includes results of strong economic interest in terms of grades or width, detecting large alteration systems likely to host mineralization, or upgrading target to a promising prospect, for example. These numbers shown here are graphically shown on the next slide. If the question was mineralization asked, the study found that 79% of reports will indicate mineralization is encountered. But as it is early exploration, there is no quantifiable data to predict a road to resource, deposit, production, or not. The bar 4 represents discovery is probably the most realistic assessment and approximation of the success of the co-funded drilling, where if the question of high grades and widths were encountered was asked, 26% of reports answered yes, and 51% of reports indicated no. A reflection of that success is shown here, where a total of 35 projects have mineral resource estimated prior to, as a result of, or since co-funded drilling, or drilling below or down dip of an existing resource, drilling along strike and proximal to existing resource, or have high grade shallow mineralization suitable for mining by prospectors without needing formal mineral resource estimates. The key to this table shown here is with the darker green is where we now have an operating mine, such as that where Sirius and later IGO are now mining Nova, or we move to a mine site where there is planning and feasibility happening, such as that seen here where Drager Resources, who later became Bellevue Gold, are moving forward. If we now move to look at the spatial distribution of the co-funding with respect to the 8,000 plus drill holes, the map on the left, and the tenements on the right, there is clearly a predominance of projects in the western 2/3 of the state, whereas the eastern third of the state has much poorer coverage. The areas of lower activity can clearly be attributed to categories such as significant cover of depths, overlying potential mineralized basement, high costs related to remote access and minimal infrastructure, and the lack of data. Going forward, the GSWA is addressing this data issue, particularly in the area we refer to as the gap, shown here in red. Projects will include collaboration with Geoscience Australia on AusLAMP, dealing with magnetic tellurics, and AusArray, passive seismic, and coil tube drilling with the Minix CRC project, to name a few. In this slide is a schematic representation of the spatial distribution of tenements listed in the successful applicants, referenced here as tenements then, shown in green, were plotted with the location of the drill holes completed, to see if co-funding had had a measure of success in continuing exploration. Current day tenements, referenced here and shown in the pink, might be expected to exist over areas drilled. It was found that 87% of co-funded holes are currently on an existing tenement, and at least 93% of the meters drilled are providing regional geological information on a current tenement. The Kalgoorlie and Perth core libraries now store over 677 diamond holes from co-funded drilling, equating to nearly 300 kilometres of drill core. If we now look at the add-on value of the drilling, we found that 43% of all EIS diamond core held in a GSWA core library, regardless of hole length, has been sampled by researchers. The big four sampling techniques are shown here. Geochemistry often includes trace and rare earth elements that are not done at the time companies submit the final report. Statistics for the geochemistry is now likely to be higher, with the GSWA undertaking projects such as the Eastern Goldfields barcoding project and a Mariwa project in the Patterson origin. Shown here are techniques used less frequently on the drill core. Going forward, the GSWA is considering a statewide systematic petrophysical study on EIS core to increase this number here. All EIS core held in the core libraries will be high-logged, and at the completion of this short study, nearly 96% of all EIS projects with diamond core had been high-logged. This is an exceptional work rate by the high-logging team and core staff, as other non-EIS core is also high-logged. Completed major research projects involving EIS core included M470, looking at the mineral systems on margins of cratons, the Albany-Fraser origin and nuclear basement, a case study in collaboration between Curtin University and the GSWA via a Minerals Research Institute of WA research grant. This has now been released and is available on our website. Also, stratigraphic and co-funded drilling of the nuclear basement, a similar report which has also been released. And as previously mentioned, the Eastern Goldfields barcoding project of mafic rocks, which has identified the importance of synucleotoids in gold mineralization. And this ends the webinar. For further information, please go to the webpage shown here, and I thank you for your attendance.